Howdy, it's tubalcain again, and the subject of this video is the use of the BUCK ADJUST-TRU chuck. And there are other brands of this as well, and I'm going to go over that in just a minute. But here I am at the Atlas lathe, and this is just the standard Atlas 3-jaw chuck. And we all struggle with the fact that 3 jaws usually are not all that accurate, especially as they age and you use them a lot. And some of them were not all that accurate to start with. Here, for instance, we've got a little chuck that I use all the time that's 3 or 4 thousandths runout. That's good enough 95% of the time for me, especially if it's a workpiece like this that I'm going to turn and then face and bore and do other operations that are going to true it up and bring everything into concentricity. But sometimes you want a chuck that's a little more accurate than that, and the only way you're going to get that is a brand new chuck, or to grind your chuck jaws, which I've shown in another video, and that's just very laborious. But another answer is the adjust-to-true type of chuck that allows you to bring your chuck back into trueness, you know, back to 0 or 1,000th total run out. So let's talk about that a little bit. Have you ever done this? Mounted your 3-jaw chuck into a 4-jaw chuck, and then you can true it up, and right here I'm within half a thousandth or so, and I wasted about 10 minutes doing that, changing chucks and reversing jaws and all that different all those different operations. But I basically trued it up. Well, is this a good setup? Not really, because now we have 2 places for it to slip. It could slip in these jaws, or the work could slip in these jaws. Also, we are too far out from the spindle now, so we lack rigidity and support, and that's just not good practice at all. But my point here, I'm just making a point, that you can true up a 3-jaw chuck by putting it in a 4-jaw chuck. This whole setup, of course, is preposterous, and I suppose there's people that have already cut the video off and started to make criticisms in the comments, but I'm just making a point here of the way that it was done by the BUCK chuck company. So let's go back over to the bench now and talk about BUCKs and other brands of chucks and how they're built, and really the similarities between what I'm doing here and what they have done, all in one patented chuck. See you at the bench momentarily. I have here on the bench a pair of BUCK brand Adjust-to-Tru chucks. Now, Adjust-to-Tru is their trade name. These are incredibly costly. This is a 4-incher, and this is a 5-incher. Don't even think about buying one of these brand new, because it's probably $500. But the reason I'm showing you this is how they're constructed, and then I'm going to put one on the lathe and I'm going to zero it out. But let's take a look at how these are built, first of all. And this is, you can see here, BUCK chuck, made in USA. This one has lost its badge, but it would have gone in this little hole and years ago. Now, in a follow-up video, if anybody watches this video, I'm going to take this chuck, which is one that I use on the milling machine, but it had no backing plate, and I'm going to make a backing plate, which is not just an ordinary backing plate, but well, you'll see why when we open one of these up. But I'm not going to talk about this one anymore, because this is the one that is a subject of discussion today. And this one's a little bit different too, because it is the mount on it is for the hard-hinge lathe. That I'm not sure what they call the nose on a hard-hinge lathe, but you're going to see mine here in a minute when I go over there. Some of these chucks are kind of thick right here, and you'll see why in a minute. But before I go any farther, let me just show you here some different brands of chucks and what they call their chucks that are similarly built, really 3-jaw within a 4-jaw. And there are probably a lot of other brands here too, but these are just ones that I looked up and I was able to come across easily without too much research, but the Bison brand is called a Set-Tru. Buck, again, Adjust-TRU. That's how it's spelled. The Bernard Pratt, and that's from England, is called the Grip-Tru. Rom is called the High-Tru. South Bend had one called Zero-Tru. They probably didn't make their own chuck, so that might have been a Buck. I don't know for sure. And South Bend's long out of business, although now it's owned by Grizzly. And finally, Gator, which I never heard of, is called the True Adjustable. So you can look for those names in the several pages of chucks that you're going to find in every one of the big machine shop catalogs. So enough said on that, but what I'm talking about is strictly today the Buck Adjust-TRU. Every chuck comes with a chuck key, and notice that this one has a hex key right here. And the way you zero these out, just briefly here now, is to loosen 6 screws here, cap screws, 1, 2, 3, 4, 5, 6, and don't confuse them with these little ones here on the inside. You want the outside ones loosened up ever so slightly. And then using an Allen wrench or this, it doesn't matter which you use, you can see here that we have 4 adjustment screws, socket head, and they're numbered. There's a number 1, 2, 3, and 4, and that's what makes this a 4-jaw within a 3-jaw. Or is it a 3-jaw within a 4-jaw? Also on this one, I've marked this so I don't move the wrong one, but on the hard-hinge lathe, this particular screw is used to lock the chuck onto the spindle, and so ignore that for the purposes of this discussion. So once I mount this, I'm going to indicate it and see how far off it is, and I don't remember because it's a long time since I've used this. And I'm going to make no chips in this video at all, just show you how to do this. And the first thing I'll do after indicating it is to loosen up these 4 cap screws, and then I'm going to adjust it back into 0. And I think this one's 1/1000th or 2 off. So let me mount this on the hard-hinge lathe. And remember, my hard-hinge lathe is actually a half a lathe. It's what they call a speed lathe or a second operation lathe. It's a short, stubby bed without a tailstock, but it's handy for chuck work. And that lathe came equipped with collets and a 3-jaw chuck when it's new, and there are probably a lot of other work-holding fixtures or devices that came with it. This chuck was damaged by somebody here where they ran the tool into the hardened jaws. Probably many years ago. It wasn't me. I have cleaned real well and oiled both the male and female, and it just goes on like that and twists. I like to twist it this way, and using a hex key, tighten it up a little bit, and it's not going anywhere. Now, if you're going to put one of these on and not take it off for years, make sure it's well oiled and that you remember which way you oriented it, because it may be a struggle for you if it hasn't been off in 10 or 20 years. Before I go over to the hard-hinge lathe, let's take a real quick look at what's inside of these Buck Adjust-TRU 3-jaws. Also note that I do have the extra set of jaws for this chuck, and for this chuck too, for that matter, which I was really lucky to have, because when you find used chucks, usually you get, well, you don't always get these jaws, but I tell you, I got a whole drawer full of jaws that came with one lathe, and they don't match up with anything. So some of them are serial numbered. Well, I'm getting off the subject there, but let's take a look at this little one first, because I've already got it apart. And in order to open it up, and you won't need to do that really, you just loosen these up ever so lightly, as I told you. But I've got them all released, and this was the chuck that was just mounted on this base plate a few minutes ago, and I took it off. So turning this upside down. That plate goes on like that. Actually, a little bit. You might think it goes this way, but it goes this way. Now this is what's sometimes called the, well, maybe not. Sometimes it's called the registration boss on other chucks, but maybe not on a Adjust-TRU. But can you see the little marks here? 1, 2, 3, 4. Some show up a little better than others. But what those are doing, when you look inside of the chuck here now, and I've backed those off a little bit, but that's the forejaw part of it. So if you look here, each one of these little pins here corresponds to one of the 4 cap screws out here. So in order to adjust these chucks, again, loosen these 6 ever so slightly, and then by tightening and loosening these, just as you would in a regular four-jaw chuck, you will have some movement to correct these. Now, not a whole lot. Let me close up and you can see that really there's only a few thousandths. I didn't measure it, but perhaps 10 thousandths that you can move it in 2 directions. So if you mangle the jaws or just plain ruin them, you're not going to be able to bring it back in, but you do have that much adjustment. And then after you get it back on to 0, we're going to use a dial indicator, then we would tighten the 6 cap screws out here again. So now we are truly going to go over to the Hardin's lathe and fit this other chuck up. This is my little Hardin's speed lathe, and you've seen it before, but not too much. I really don't use it all that much. But that's all there is to it. And they made a lot of these. Now the compound here can be removed real quickly, and I'm going to do it right now just to have it out of the way and really to show you how it's done. But to take the whole cross slide assembly off here, all we got to do is loosen this lever back here, and off it comes and it's out of the way, and I'll just set it off to the side. And what I just set on the floor there is probably worth $1,000. And this is in perfect shape yet, so I'm going to protect that as I work up here on the spindle nose. Now take a look at that spindle nose, and that's what it looks like on a Hardin's lathe. And they use that spindle on, oh, I don't know how many models. Maybe they still use it. And see, there's a little bit of a slot here, and then a slot that goes in both directions here, and that's what lines up with this little pin right here. So I'm going to clean it up real good and put it on. Real well, that is. I have cleaned real well and oiled both the male and female, and it just goes on like that and twists. I like to twist it this way, and using a hex key, tighten it up a little bit, and it's not going anywhere. Now if you're going to put one of these on and not take it off for years, make sure it's well oiled and that you remember which way you oriented it, because it may be a struggle for you if it hasn't been off in 10 or 20 years. Okay, here's the setup. I'm just using my little fake Noga indicator holder here with a plunger type of indicator. I prefer a plunger type for this, but that's up to you, of course. And I like to work toward me and away from me when I use a four-jaw chuck, so that's the way I'm doing it, but you know, whatever turns you on. But notice now, when I zoom in a little bit on this this indicator, that this chuck is about 4 thousandths off. About heck, it's exactly 4 thousandths off. Alright, so what I'm going to do is to loosen, again, these 6 cap screws just a little bit. Quarter, a turn, eighth of a turn, not very much. And then I'm going to start working this as if it was just a regular 4-jaw chuck. So I'll loosen these up off camera. It's just a matter of doing this. There's no spindle lock on this machine, so I have to pull the plug. I've already turned the plug off. If you're doing something like this and you're going to hold on to pulleys or belts, make sure you unplug the machine, because you can always bump a switch. That's the safety tip for today. And because I'm not working under power. And then I will loosen these up and get back to you. Note that I do have the power turned off. These cap screws were much tighter than I thought. Probably never been loosened, at least never by me. So I had to use a couple Arkansas socket wrenches, one holding on to the jaws and another just as a cheater on my hex keys, like that. So they're all backed off ever so slightly. And now we can go to work. Okay, a couple things now. First of all, I protected the bed with a blue rag here, a surgical drape. And the material I have in here is a piece of 3/4 inch drill rod. Now, the reason I use ground drill rod is it's truly round. And if you use a piece of cold roll, it might be slightly out of round, and then you would be getting a slightly wrong reading, bad reading. So now, again, working these two, I like to use 2 wrenches now, one on the front, one on the back. Working one against the other, I will be, boy, these are tight too. I think I'm going to have to back those off. There we go. They're loose. I'm going to bring that one in. I'm going to rotate it 180 degrees. And I'm within a 1/2 thousandth. And I marked these with a Sharpie. But I can see I'm instantly wiping it off, so that was for naught. So I'll split the difference there. No, it made it worse. These are awfully tight. Alright, I'm going to work a little bit off of camera now so that I can speed things up, since still a little bit off. Well, that didn't take long. That was just 2 minutes, really. But you can see I'm in contact with the work, and I'm within, I wish I would have used a 1/10 of a thousandth indicator, but you can see I'm probably within, oh, it's a 1/2 thousand, so 2 or 3 or 4 10,000ths, so it's really spot on. Next, I will snug up these 6 cap screws. I'm going to see if it changes at all. So I'm going to snug them up equally as we would an engine head, going all the way around, crisscrossing and all of that. And hopefully it will not make any changes here. And at the present time, I've got these tightened one against the other. So that shouldn't move. Okay, finally here I'm done, and you can see just a little deflection on that plunger type indicator. So I went ahead and I put the Federal test indicator on there, and that is see the pointer, and with a different base. That's a magnetic base, and this thing reads in half thousandths. I guess I don't have one that reads in tenths of a thousandth. I thought I did, but of all the indicators I've got, this is the most accurate. Well, I got a bunch of these different brands, but you can see that we've got a half a thousandth. You're thinking, what do you mean we? You've got a half a thousandth. So my Federal Testmaster made in Providence, Rhode Island is showing a half a thousandths of an inch in runout on the BUCK ADJUST-TRU chuck. And you know, that's only 1/4 the thickness of a hair, or approximately a blonde hair. So that's going to be close enough. I could work at it and probably get it right on, but the reality is this is about it. Most collets, unless they're hard-inch collets, aren't going to run that true. So that is how you adjust and adjust a true chuck. And that's it, ladies and gentlemen. If you remember how I started this video out, holding a 3-jaw chuck in a 4-jaw chuck, and how bulky it was, and here we have it all in one with a BUCK ADJUST-TRU chuck, and how to zero them out. And be sure and watch the companion video. That will be one of the next videos, where I show how to put a backing plate on that other little BUCK chuck. Hope you liked this video. This is tubalcain saying so long for now, and I'll see you in my next video.